Good morning, everyone. Thank you for joining Steam Management Showcase webinar. Today's topic is Steam Trap Monitoring Solutions, presented by Ian Geiger from Armstrong International. At Steam Management, we focus on improving the efficiency and performance of Steam and other utility systems. We work across K through 12, municipal, higher education, federal, healthcare, commercial, and industrial markets. We work with our clients from identifying Steam system improvement opportunities all the way through design and implementation. We try to look at the Steam system as a whole and identify practical opportunities to reduce energy and water use while improving reliability and safety. Steam trap performance is obviously an important part of that, which makes today's topic especially relevant to the work that we do. For those that don't know me, my name is Chase Bean. I'm the Vice President of Revenue and Engineering here at Steam Management, and I will be your host today. If you have any questions during the webinar, please feel free to post those in the chat, and I will be monitoring those throughout the presentation. We'll also have a few polls during the presentation, so please participate when those pop up on your screen. PDA certificates are available for attending. If you like one, just email me at my email address there, cbean@steammgt.com. And we will also make this webinar available on our website, along with previous webinars at steammgt.com/webinars. That's usually available shortly after we finish. Today, we're joined by Ian Geiger from Armstrong International. Ian has been with Armstrong for 6 years, supporting steam and condensate applications across roles, including product manager, application engineer, and project manager. In his current role, Ian oversees Armstrong's steam trap management platform named SAGE, as well as the development and deployment of Armstrong's trap testing solutions, including the UMT handheld testing device and the SteamEye continuous monitoring system. For anyone who may not be familiar with Armstrong, they've been in the thermal utilities business for more than 125 years and are a fifth-generation family-owned company. They have more than 3,000 employees worldwide and provide a broad range of thermal utility solutions, including steam and condensate, hot water, heat transfer and heat recovery, heating and cooling, humidification, flow measurement, remote monitoring, and software. Armstrong represents a legacy of continuous innovation, delivering technologies that redefine industry standards. For clarity, Steam Management specs equipment based on our clients' needs. We do not represent any manufacturers, and we are not officially affiliated with Armstrong or their products. That being said, Armstrong is a trusted supplier, one of the most established names in the steam industry, and we frequently implement their equipment as part of our projects. We've invited Ian to join us today because steam trap monitoring is becoming an increasingly important topic for a lot of our clients, and Armstrong has developed one of the more recognized platforms in this space with their SAGE technologies. We see a lot of interest from our clients in SAGE because it gives facilities a way to organize trap data, track performance over time, and move toward a more proactive approach to steam trap management. We're looking forward to hearing Ian discuss steam trap monitoring technologies, different design and deployment approaches, and the key considerations that go into developing an effective trap monitoring and management program. Ian, thanks again for joining us. I'll turn it over to you. While he takes control, we're going to launch our first poll. And the poll is, have you evaluated continuous steam trap monitoring before? Okay, it looks like people have either evaluated it and are currently using it, or have not evaluated it. Their answer is either yes and we use it, or no, but we're interested, or haven't evaluated it at all. So, okay, thanks to everybody for participating, and Ian, take it away.
Awesome. Thank you so much, Chase. Good morning, everyone. Thank you so much for joining us today. I know our discussion is around steam trap monitoring, but where I want to start us off before we start talking about monitoring, I want to take a step back and look at a steam system from a 10,000 foot view. And that's what this image is showing us on the screen today. At its most basic level, steam is generated at the boiler and distributed throughout the facility to various applications. The steam may be used for heating, process equipment, sterilization, humidification, or many other purposes, depending on the facility. As steam gives up its energy to perform the useful work, it condenses back into water, which we refer to as condensate. That condensate needs to be removed from the system while keeping the valuable steam where it belongs. That's where steam traps come into play. All right. The primary purpose of a steam trap is simple: allow condensate, air, and other non-condensable gases to pass while preventing live steam from escaping. And in many ways, steam traps are really the gatekeepers of a steam system. They help ensure that energy you've paid to generate is actually utilized in the process rather than being lost to the condensate return line. Once the condensate passes through the steam trap, it enters the condensate return system and it's sent back toward the boiler where it can be reused. This cycle repeats continuously throughout the facility. When steam traps operate properly, the entire steam system runs efficiently. When they don't and steam traps start failing, a variety of costly problems begin to develop. Now, steam traps are mechanical devices. They are going to fail at some point, unfortunately. So it's not so much when a question of if a steam trap is going to fail. Unfortunately, it is when is it going to fail. And steam traps generally fail in either one of two ways, and that is they either fail open or they fail closed. What we're going to take a quick look at is what happens if a steam trap were to fail closed. Well, a failed closed trap cannot properly remove the condensate from the system. Instead of draining away the condensate, it begins to accumulate upstream of that trap. This can create wet steam conditions, which reduce the amount of usable energy available to the process. As condensate accumulates, it can lead to water hammer, which many facilities know all too well. Water hammer is not only loud and disruptive, but it can also cause serious damage to piping, valve, support equipment, and also cause significant safety concerns. And heat transfer applications, condensate that backs up from a failed steam trap. It can flood heat exchangers and prevent steam from contacting that heat transfer surface. This results in reduced heating capacity, lower production rates, inconsistent operations, and in some cases, lost batches or reduced product quality. Essentially, failed closed traps can also contribute to corrosion issues, thermal stress, and buildup of non-condensable gases. Air also acts as an insulator and it does reduce heat transfer efficiency. While oxygen and carbon dioxide, when mixed with cool condensate, they create essentially create carbonic acid, which is going to eat away at your system. So the bottom line is a failed closed trap often impacts your reliability and your production. Now, we mentioned failed closed traps. What about a failed open trap? Well, looking at a failed open trap, when a trap fails open, live steam is allowed to pass directly into the condensate return system. Instead of just removing the condensate, the trap is a leak point of energy and dollars, in all honesty. The most obvious consequence of this is that energy lost. The steam that was intended to provide the useful work is now being discharged directly into the return system, wasting fuel, water, and treatment chemicals. As more steam enters the condensate return line, back pressure begins to increase. This increase in back pressure makes it harder for not just the current trap, but the neighboring traps to discharge condensate effectively, which can create secondary problems throughout the system. Heat exchangers can begin to stall. Surrounding traps may struggle to operate correctly, and overall system efficiency begins to decline. Failed open traps can also create safety concerns due to excessive temperatures and escaping steam. Beyond the monetary losses, they can also have environmental impacts because the additional fuel that must be burned to replace the wasted energy. Unlike failed closed traps, which often impact reliability and production, failed open traps are typically the major source of energy losses in a steam system. Now,
Hey,
why?
Ian, I'm
Yes,
gonna
go ahead.
jump in real quick. Let's do another poll here before you
Okay,
get to the
absolutely.
next. And this poll is: how does you or your customer's facility currently identify failed steam traps? Okay, we got some participation here. A lot of people saying annual trap survey, reactive maintenance after a problem occurs. That's not surprising. And a few people doing continuous monitoring or not really having a formal program. So this is going to be good information for our audience here. Thanks, Ian.
Of course. Thank you, Chase, for the poll. Moving on into the discussion, based on the two problems or the two ways that steam traps can fail, when we look at these potential issues, it becomes clear why steam trap monitoring is so important. The reality is that steam traps are mechanical devices, as we said, and that they are going to eventually fail. Industry studies consistently show that somewhere between 5 and 15% of steam traps in your population are going to fail annually. This is good news when you routinely test your traps and quickly replace failures. You can actually reduce that overall failure rate in your system. Many customers don't realize this, but failed traps often contribute to that premature failure of nearby traps. A healthy system tends to stay healthy, and an unhealthy system tends to often create a cycle that leads to additional failures. Another important point is that most steam traps cost significantly less to replace than the losses that they create when they fail. And for many customers, steam traps are one of the quickest wins available in their facility. The payback period is often measured in months, not years, when it comes to steam traps. The energy savings can be substantial, maintenance issues can be reduced, and overall system reliability improves. If you're looking for a starting point to improve a steam system, identifying and repairing steam traps is often one of the highest return projects available. Now, so how have steam traps traditionally been monitored? Historically, most facilities perform an annual steam trap surveys using a combination of temperature testing, acoustic testing, or both. This may involve infrared temperature guns or ultrasonic listening devices, or even Armstrong's UMT, which is a wireless trap tester that combines both the temperature and acoustic technologies. And to be clear, we absolutely recommend performing these surveys. Testing your traps annually is far better than doing nothing at all. However, there is a fundamental limitation. Imagine you test a steam trap in April, as we can see on the screen, and determine that it is operating perfectly. Then 2 months later in June, that same trap fails open. The problem is that you may not find that out until your next survey a year later. That means a trap could be operating in a failed condition for roughly 10 months before anyone discovers it. Now, just to get an idea of what that kind of impact is, let's put some numbers to it. If that trap happens to be a drip trap on a 150 psi steam line with a 1/4 inch orifice inside of it, which is very common application and orifice size in a steam trap, and let's say the steam costs approximately $10 per 1,000 pounds of steam at that facility, which is a very normal cost, at least here in the Midwest, that single failed open trap can easily waste around $20,000 before the next annual survey comes around. So while manual testing is extremely valuable and but some customers want greater visibility of what's happening in between those inspections. They want to know when a trap fails, not months later during the next survey. And that's where continuous 24/7 wireless trap monitoring starts to become more attractive. For Armstrong, that solution is SteamEye, essentially. All right. Now that we've established why monitoring steam traps is important, let's talk about Armstrong's steam trap monitoring solutions, known as SteamEye. A SteamEye system is made up of several key components working together to provide 24/7 visibility into the steam trap population health. First, we have the transmitters. These are field devices that are installed throughout the steam system at the steam traps and are responsible for collecting data from the traps. Next, we have the repeaters. The repeaters are used when additional signal range is required, when obstacles make wireless communication difficult. They simply extend the communication path between the transmitters and the receiver, or also known as the gateway. And finally, we have the gateway, which is also known as the receiver. The gateway collects information from all of the transmitters throughout the facility and makes that information available to maintenance personnel and system administrators. Together, these components create a wireless monitoring network that continuously monitors steam system health and alerts personnel when issues are detected. When it comes to the transmitters themselves, Armstrong's has two different monitoring technologies. The first is conductivity-based transmitter, and the second is ultrasonic and temperature transmitter. Each technology serves a different purpose and is optimized to different applications within the steam system. The conductivity technology is primarily used with Armstrong inverted bucket steam traps and certain condensate handling equipment where the liquid level inside the equipment can be monitored directly. The ultrasonic and temperature technology is designed to continuously monitor virtually any type of steam trap. And we'll cover that technology later in the presentation, but let's start by taking a closer look at the conductivity monitoring. Now, conductivity monitoring is one of the simplest and most reliable methods to determine the condition of an Armstrong inverted bucket steam trap. This is specific to this type of trap, monitoring this type of trap, that is. In this design, a conductivity probe is installed into the bottom of a steam trap itself. The probe is looking for the presence of condensate inside the trap. Since water conducts a little bit of electricity and steam does not, the system can determine the condition of the trap based on whether conductivity is present. Under normal operation, based on the normal operation of a inverted bucket trap, condensate collects in the trap and maintains conductivity across the probe. It also contains a temperature sensor that will alarm if the temperature drops below the set point. This provides a simple, robust, and highly accurate method for allowing to know if the trap is operating correctly or not. Now, when we look a little deeper into how this one works, it's quite straightforward. If the trap develops a blow-through condition and begins passing live steam, the condensate level inside the trap drops or even disappears at times, inside the inverted bucket trap, that is. Once that liquid level drops below the probe, conductivity is lost. The SteamEye transmitter immediately recognizes that loss of conductivity and communicates the alarm back through the system. This allows maintenance personnel to identify when an inverted bucket trap is failed and can quickly see that rather than waiting until the next survey or inspection whenever something fails, as you guys were referencing earlier. The result is a faster detection, faster repairs, and reduced energy loss. Now, one of the most common applications for where this type of unit is specifically used, it's most common in vaults and tunnels. Many facilities have steam traps located in areas that are difficult to access and require special safety procedures or simply do not have or do not receive regular inspections. These locations are often ideal candidates for continuous monitoring. In addition, vaults and tunnels can create challenging conditions for traditional monitoring equipment due to the poor wireless signal strength and elevated temperatures and harsh operating environments for the equipment that would be placed in there. By utilizing a remote conductivity monitoring solution, facilities can maintain visibility into steam trap health without requiring frequent personnel access to those difficult to reach areas. These locations often become the perfect candidate for continuous monitoring because maintenance personnel may not routinely visit them. Rather than requiring someone to physically enter a vault or tunnel to verify trap operations, SteamEye provides the continuous visibility from safe and accessible location. For many customers, these locations are among the first places where they're looking to implement this type of monitoring. Here we have a picture of a typical installation on a vault or a tunnel for this type of remote conductivity unit. In a typical vault application, the conductivity probe is installed directly into the bottom of the Armstrong inverted bucket trap located inside the vault. The transmitter is then wired to the probe. However, instead of placing the transmitter inside the vault itself, we mount this in a nearby accessible location so that and this provides several advantages. First, maintenance personnel can easily access the transmitter where the battery is held. Second, wireless communication is often improved because the transmitter is not buried underground or surrounded by concrete structures. And finally, allows the customer that continuous monitor equipment located in the difficult to reach areas. Now, while conductivity monitoring is commonly associated with Armstrong steam traps, the technology can be used for other applications as well. One example is condensate pumps and receivers. In these systems, conductivity probes can be used to monitor liquid levels and detect abnormal operating conditions. For example, if a receiver begins flooding or condensate levels rise above the expected limits, SteamEye can provide an alarm so maintenance personnel can investigate the issue before it affects the system operation. This gives customer additional visibility into critical condensate management equipment beyond simply monitoring steam traps. Another application that these conductivities are used in steam coil protections. This is a big one. Many facilities rely on steam coils for heating and process applications. If condensate begins backing up into a coil, performance can suffer significantly. Heat transfer efficiency decreases, and process temperatures can become difficult to maintain. And by monitoring the condensate levels, SteamEye can provide an early warning that the flooding is occurring before more serious operational problems develop. This allows maintenance teams to proactively address those issues before they have to go and fix those types of issues in the field and wait for the problem to actually, the issues to actually impact the system. Now, this slide is an example of how those types of units are typically installed. They're not technically installed right on the steam trap. As you can see, they're installed right in front of it. This is just an example. In this application, the goal is not necessarily to monitor the trap itself, but to determine whether condensate is backing up towards a coil type situation. If condensate begins accumulating upstream, it can indicate a drainage problem, a failed trap, or excessive back pressure, or any other type of system issue. And for process equipment, this backup can reduce efficiency, lower production rates, negatively impact overall operations. And for customers located in colder climates like us up here in Michigan, particularly up here in the northern states or in Canada, condensate backup can create a really big concern when you encounter freezing conditions where those flooded coils are really going to start getting damaged from frozen water. Detecting these conditions early allow maintenance personnel to take a corrective action before equipment gets damaged. That's the key to this. And so that is not, so not only can these units be utilized to monitor steam traps, they can also be utilized to monitor other operation and equipments in your system to give you that greater visibility. Now, Chase, before I jump in ultrasonic and temperature, you want to poll?
Before we go on to, yeah, we got this poll before we move
Perfect.
on. Yeah. Next poll is, what is the biggest barrier to implementing a steam trap monitoring system? Is it upfront cost? It's more trouble than it's worth. Installation complexity, IT or network or cybersecurity concerns, difficulty getting signal from trap monitors, or the facility has hazardous area requirements like class 2 or hazardous gas or dust or other. Okay, we got about 30 responses. It looks like a little over half of people are saying the upfront cost. Thanks, Ian.
Absolutely. Absolutely. All right. So that was the conductivity unit. We said there was 2 types of units. That was all about conductivity. It's very specific to Armstrong steam trap equipment. But let's jump into the one that's most commonly used in the industry, and that's the ultrasonic and temperature units. Unlike the conductivity unit, which is primarily used on the Armstrong inverted bucket traps, like we said, in level applications, the ultrasonic and temperature transmitter can be applied to virtually any type of steam trap. This includes inverted bucket traps, float thermostatic, thermodynamic traps, thermostatic traps, and many other trap designs. The transmitter continuously monitors 2 critical parameters, and that is the temperature and ultrasonic activity. By combining both pieces of information with Armstrong's algorithms, the device can determine the operating condition of the trap and wirelessly communicate that condition back to the system. This makes the ultrasonic and temperature transmitter an excellent solution for facilities that have multiple trap technologies installed all throughout their steam system. The monitor, now how does this unit work? Well, the monitor is mounted on the inlet side of the steam trap, which generally within 6 inches, which is what we recommend of the inlet of the trap, that is. The installation requirement is important because we want to accurately measure the temperature being seen by the steam trap itself. The first thing the device does, it takes a look at temperature. If steam is not reaching the trap, or the trap is plugged, where the trap has failed closed or the application is stalled out due to undersizing or excessive back pressure, the monitor will report back in a cold condition. Once the trap reaches its configured temperature set point, we can confirm that steam is present, essentially. So we do a temperature check. If it's cold, it reports back as cold. It stops. It's just going to communicate that. But if our temperature set point is achieved, then the monitor begins listening to the trap using ultrasonic technology. Every steam trap sounds a little different depending on the trap type and operating conditions. However, one general rule tends to remain true across the technologies. A healthy trap is typically hot and relatively quiet. When a steam trap fails open, live steam begins passing through the trap's orifice, and as steam rushes through that orifice, it generates ultrasonic noise levels that are significantly higher than that of a healthy operating trap. The transmitter detects that increase in ultrasonic activity. When it goes above that threshold, it flags the trap as a blow-through condition, allowing maintenance to react to that and replace the failed steam trap. Now, just like conductivity units, ultrasonic and temperature units can be used on other applications as well. And one of them is safety relief valves. Safety relief valves are critical assets that protect equipment and personnel. While these valves are designed to remain closed during normal operation, they can sometimes develop a leakage. Even a small leak can result in energy loss, process issues, and maintenance concerns. By continuously monitoring temperature and ultrasonic activity around these valves, SteamEye can help identify leaking valves quickly so corrective action can be taken before the problem grows. So it's not just steam traps that we're able to give you that visibility on, but also another point where energy is sometimes lost is that valve testing for that safety relief valve. Now, at this point, let's discuss. We have a little bit of a naming convention when it comes to this slide. The conductivity units are known as the RFC 4300 transmitters, and the ultrasonic and temperature units are the URFC 4700 transmitters. These installation drawings show on this slide, and they illustrate the proper application of each technology. One of the most important selection criteria is steam pressure. The question is generally asked, hey, when do I use a conductivity unit? When do I use a temperature and ultrasonic unit? This is one of the main determining factors. It's the pressure. All right. The conductivity units are typically used on applications operating anywhere from 0 to 15 psi. All right. And the ultrasonic and temperature units are used on applications above 15 psi. The reason for this is quite straightforward. At pressures below 15 psi, steam simply does not generate enough ultrasonic noise for the current sensor to consistently distinguish between a healthy trap and a failed open trap. So it has a harder time distinguishing a blow-through trap under 15 psi. Because of that, the low pressure applications rely on that conductivity monitoring rather than the acoustic monitoring to make sure that we're correctly flagging our failed open traps. Another important detail is that the installations show on this slide that they are for constant pressure applications where steam is continuously available at the trap. Now, what if that's not the case? What if steam pressure, we know what it is, but it's not a constant pressure application? What if we have a different situation? That's when we look at our RFM 4300 and our URFM 4700. When we're dealing with modulating steam applications, steam is not always continuously fed to applications. In those cases, we utilize these modulating units, essentially. They're the same exact units, but with an additional component, and that is they require a pressure switch. All right. The pressure switch confirms whether steam is actually being supplied to the application. This prevents the monitor from reporting false cold alarms when steam supply is intentionally closed and no steam is present. Without the pressure confirmation, the system would see a cold trap incorrectly and assume that a problem exists. The pressure guidelines remain the same. Conductivity-based solutions are generally used on the application below that 15 psi, and ultrasonic and temperature monitoring is for 15 psi and up. The key difference in this installation method is the use of those pressure switches to verify that the steam is actually present and that we're actually identifying failed traps under correct conditions. Chase, before I move on, do we have another poll or would you like me to continue?
Yeah, that's a good spot for it. Next poll is, sorry, I lost it there. When a steam trap fails at your facility, how quickly is it typically identified? Same day, within a week, within a month, during the next scheduled survey, or it can go unnoticed for long periods. Okay, we got a good portion of the audience has responded, and over half are saying that they can go unnoticed for long periods, which is not surprising.
Awesome.
Yeah,
Thank you,
thanks, Ian.
Chase, for that poll. Now we've discussed the monitor side to the SteamEye system. What about the other components? Let's start with the repeaters. Net, repeaters have a very simple job within a SteamEye system. They receive signals from the transmitters and retransmit those signals to extend range and improve communication reliability. They are commonly used when transmitters are located a long distance away from the gateway or when physical obstacles such as buildings, equipment, tunnels, walls, or other structures interfere with wireless communication. Rather than running wiring all throughout the facility, repeaters allow the network to expand wirelessly while maintaining a strong communication path back to the gateway. They are particularly useful in those larger facilities, district energy systems, campuses, and facilities with underground vaults and tunnels where direct communication may be difficult. And the other component that we referenced at the beginning, the gateway, or also known as the receiver sometimes. The final piece of hardware is that gateway. The gateway serves as the central communication hub for the entire network. It collects information from, it does collect all that information from all transmitters and makes that information available through a standard web browser interface. One benefit is that there is no dedicated software required on the user's computer. The gateway can also communicate information directly into an existing facility's system using protocols such as Modbus and BACnet, allowing integration into BAS and DCS platforms. In addition, the gateway can communicate with Sage, Armstrong Steam Trap Management Platform, to automatically calculate real-time energy and monetary losses associated with failed traps, giving more visibility into what those actual impacts are for traps that are failing. Each gateway can support up to about 2,000 transmitters, allowing even large facilities to be monitored through a single system architecture. One question we receive frequently is how SteamEye and Sage work together. SteamEye and Sage are independent products. A customer can purchase and operate SteamEye without owning Sage, and there are no ongoing subscription requirements simply to operate a SteamEye monitoring system. However, when you integrate it with Sage, the value of monitoring systems does expand significantly. SteamEye provides the real-time condition of field assets, while Sage provides asset management, reporting, energy calculations, and financial impact analysis. When failures occur, Sage can identify not only which trap has failed, but also estimate the results, steam losses, energy impacts, and potential emissions impact that trap is having. This allows maintenance teams to prioritize those repairs based on business impact rather than simply responding to alarms. The gateway only requires an outbound internet connection for communications to the Sage platform. Another common question that we do receive as well is how the devices communicate with each other. It is wireless. SteamEye operates on a 902 to 928 megahertz radio frequency spectrum. The system uses the proprietary spectrum technology and channel hopping technique to provide a robust wireless communication throughout the industrial environment. Under an ideal line of sight conditions, that's ideal, that is, communication distances can reach 1,500 feet. But most commonly, in all honesty, in typical industrial environments with obstructions such as equipment, walls, and structures, communication distances are usually that 300 to 500 feet range. When additional distance is required or obstacles become problematic, that's when those repeaters are installed in order to extend that communication. This is typically identified during an RF survey that we heavily recommend. We say that's the first step in a SteamEye system, is get in an RF survey to figure out what type of radio frequency communication capability your facility will have, to get an idea of how many repeaters would be needed, to figure out if communication is viable based on equipment and infrastructure. The first typical step in this is that RF survey that occurs. So before we wrap up today, I'd like to leave you with a message that has been a core part of Armstrong for many years. Knowledge not shared is energy wasted. It's one of our company mottos. Armstrong has spent more than a century helping customers improve performance of their thermal utility systems. Over that time, we've learned a tremendous amount about steam systems, condensate systems, heat transfer, reliability, energy efficiency, and best practices. And the value of that experience isn't just in having the knowledge, it is in sharing it with our customers and partners. That commitment to education is reflected in many ways through our Armstrong Global Learning Center, Armstrong University Online, live seminars, webinars like this one, and hands-on demonstrations. We're constantly working to help customers better understand and improve their steam systems. When we think about today's discussion, steam trap monitoring is really just an example of that philosophy. The goal isn't to simply install these sensors on steam traps. The goal is to provide meaningful information that helps maintenance teams make better decisions, reduce energy consumption, improve reliability, increase safety, and lower environmental emissions. Whether you're conducting annual steam trap surveys or implementing continuous monitoring with SteamEye, utilizing Sage for energy tracking, or simply developing a better understanding of your steam system, every step toward greater knowledge leads to better system performance. On behalf of Armstrong, thank you so much for your time and participation today. I'm going to hand it back to Chase for any further questions that may be had.
Yeah, thanks, Ian. And before we get to additional questions, let's do our last poll here. This is what would be your biggest driver for implementing steam trap monitoring? And would that be energy savings, maintenance labor savings, faster identification of failures, improved system reliability, or better reporting / visibility into system performance? For prediction, what I think the popular answer would be based on our audience, and that seems to be coming true, it's energy savings. And someone wrote in all of the above, and I was just thinking we should have had that as an option. But I do like that I want to see what the priority is for everyone, because that would be too easy of an answer. Ian, I had a question for you. We often go into sites and do trap surveys, and we recommend which traps should be monitored. And typically we're going to prioritize high pressure, large orifice size, high run hour traps, right? And and then I guess additionally, we'll also, to keep costs down, we'll recommend not monitoring every single trap in the system. Yes. A lot of times that looks like a monitoring of priority traps. I should add also hard to access traps to that list of criteria, but yes. It'll look like, but anyway, our recommendation will look like monitoring of priority traps, and then RFID tags on, all the remaining traps, or at least the kind of secondary level priority traps. So interested to get your thoughts on that, or anything to add to that as far as the approach to, mapping out how you want to monitor your and manage your steam trap population.
Yes, no, that's a great question, and a really good idea to figure out, hey, what's the strategy to most efficiently monitoring your trap population? And a common one is we say, hey, process critical applications, traps that if this trap fails, it's shutting down all of production or shutting down a large chunk of production. We heavily recommend making sure that those are a part of the group that you monitor. You are right that it's not always completely reasonable to say, hey, wirelessly monitor every single trap in your population. It's a hybrid approach is most effective. So after we get away from the critical process traps or the hard to reach ones in the vaults and steam tunnels, I also emphasize, but based on your steam distribution line, the hard to reach traps that are drip traps for your steam distribution line. Because if you have 150 psi line and that steam trap fails open, not a lot of the time do people notice that that one's actually failed open. It's usually not having a ton of impact on the overall system because it's failed open. But what that one's doing is it's bleeding you of energy. You're losing a ton of energy through there, and it's being a very big purging point of cost right there. So I say hard to reach applications, not just in steam tunnels and vaults, but also on those distribution lines, on the high pressure distribution lines, to make sure you're capturing those energy losses and costs.
Yeah, that's a great point. It's kind of making me think of a certain application that we have at a facility where they just don't have a lot of valves to kind of zone different sections off to troubleshoot. Okay, which zone is this failure even coming from, right? Like they have a condensate tank that's just blowing steam, and traps are very difficult to access, and we can't even really isolate different zones of the system
Yep.
to identify where the trap failure is, or failures. So
Mhm.
that was a challenge, and that would have been a good place to have some monitors, even though I don't think the pressures were necessarily that high on those traps. But yeah, good
Absolutely.
point. Well, great. We'll hang on for a little bit and answer any more questions, and Ian can answer questions as well. But I do want to, before anybody drops off, I do want to thank everybody for attending and thank Ian for presenting. We do have our next webinar slated for September 29th. That's going to be about the difference between low pressure and high pressure steam systems, because there's really a lot of differences as far as the design, the requirements, the applicable codes, the energy savings measures in particular, we'll look at as well. So I think that's going to be a really good topic, and we look forward to seeing you there. I'll remind you again, if you want a PDH certificate, the process for that is just to email me at cbean@steammgt.com. And this presentation will be available at steammgt.com/webinars. And we have, I think we counted, this is our 23rd webinar. So we have a pretty good library of webinars about mostly about steam systems. So you should check that out. Oh, okay. I'm seeing a whole list of questions here, and people are posting in the Q&A section. And I was just kind of looking at the chat section. So got some questions here for you, Ian. I will go from the oldest questions up. And first one I see is there a simple cost per trap for these systems?
That's
Go ahead. I'll let you take that.
Well, first off, that one was a comment under can SteamEye system monitor all other manufacturers' steam traps or just Armstrong? And just to get an answer on the main post of that one, yes, it can. It depends on the type of monitor that you're utilizing. The conductivity units, unfortunately, are Armstrong specific. However, ultrasonic and temperature units, which are the most commonly used ones out there, those can be used on any type of manufacturer. It is not specific to it. Is the comment on that, is there a simple cost per trap for these systems? It completely depends on the number of traps that you are looking to monitor. The more you're looking to monitor, typically the larger the benefit and the lower the cost of it all.
Yeah, and that reduces the cost of the gateways, the cost of the surveying and the implementation overhead. So the more traps, the better. And I was just thinking, we see a lot more ultrasonic traps than conductivity, or ultrasonic meters rather than conductivity monitors. And I think the main reason for that is what Ian mentioned earlier, is that the conductivity monitors are more for below 15 pounds. And
Yes.
when we recommend monitors, we're usually recommending higher pressure traps, unless there's some, it's a critical process or something like that, like Ian mentioned.
Yeah, absolutely.
Next question. Ultrasonic can be installed without an outage, correct?
Yes, the ultrasonic and temperature units that are universal, they're simply clamped onto within 6 inches of the inlet of the steam trap using a waveguide that you clamp onto the pipe. It does not go inside the trap at all, does not go inside the pipe at all. It is fastened to the pipe. So you do not need an outage to install a large number of ultrasonic and temperature units.
Yep. And next question is, does the Gateway 4000 series have an insert SIM card?
That is a great question, and I believe that question was from Marco. I would love to confirm that internally. My current understanding, no, it does not have an insert SIM card. But if it's okay, I would love to confirm that internally with our instrumentation engineer and get you an official yes or no on that, if that's okay.
Yeah, definitely. And I'll let you follow up with Mark there, Ian.
Perfect.
And okay, next question. Most of the traps I encounter are from different OEMs. Is the ultrasonic monitoring system universal? I think we've talked about that it is. I want to add to that. Is there anything that you consider for monitoring different types of traps? I think a lot of us know that, bucket traps operate differently than thermodynamic traps. Um, do you have different algorithms for different traps, or how does the system identify different types of trap failures?
As far as the algorithm is generally the same. I guess is the question towards if it's an F and T instead of an inverted bucket, does it listen to it in a different way? Um,
Mhm.
the answer would be yes. There is a slight difference. Use the same algorithm, but it's adjusted per each trap technology, essentially.
Okay, interesting. Um, that's all the questions I'm seeing right now. I'm gonna go back to the chat, actually. Might be something there. Um,
We did have, it looked like someone else did ask the question of is ultrasonic monitoring system universal? Yep, that one was answered by actually our local rep, Roger Schultz. And then we also did have does the end user own the equipment and manage data themselves, or is it managed via a third party like our local representative team that we have nationally? I have, I know it sounds like I'm copying what the question is. I have seen it both ways. I have seen some customers come in and say, hey, they want to manage it from beginning to end. They're going to watch it all. I have seen some say they want the information sent to our Sage trap management platform where our local rep will help them monitor it to make sure that they are aware of steam trap failing. But usually for something like steam trap monitoring from SteamEye, it is heavily customer involved. They have a ton of visibility on it, and they're working continuously to try to replace traps that are failing, and they're looking to stay on top of it.
Next question I see, can the monitor be installed on all pressure relief valves or only on steam pressure valves?
As far as the ultrasonic units, the ultrasonic and temperature units, generally they're utilized on steam pressure reducing or steam pressure relief valves. We don't have a lot of use of them outside of steam systems just because the reason why is the most amount of value comes from these types of units when they're paired with the rest of a wireless infrastructure. So having monitoring 3 or 4 pressure relief valves that are not on a steam system might not be economically viable. It's typically when customers are monitoring 50 steam traps and they want to monitor their pressure relief valves on their steam system. So that's usually where they utilize that.
Okay. Ian, our Eli Meyer has a question, and I think this is interesting because I had a similar thought when you were showing the air handling unit application. But the question is, can the conductivity monitors not be installed upstream of a trap in a well or pipe tee and still work for a non-Armstrong trap? So I think he's saying you could put a well or pipe tee upstream of a a different manufacturer's trap and then monitor the conductivity of that. Is that
That is
commonly done, and is it possible?
I wouldn't say it's commonly done, but it is something that you could do. It's actually a very interesting concept. Is that installation image that we did show you, that would monitor, you could put it upstream of another manufacturer's trap if it's below 15 psi, and you want to know if it's flooding and backing up, that would be the way that you could measure. However, when that happens, it might it's not usually able to catch in that specific type of application. It's not catching the blow through traps in that situation. You would only be catching the trap if it was flooding. Um, and that's because in order for the conductivity units to flag a flooding situation, like in coils, in pumps, in receivers, or in that installation where we said, hey, we can install it upstream of a F&T in that image that I shared to see if that F&T is flooding, we do have to alter the code a little bit for it to flag any type of flooding that's going to encounter. So it's no longer using the exact same code that would be able to monitor for a blow through trap. So you could do it. It's just not as much values there. That's when people are generally looking for the ultrasonic and temperature method, and kind of doing that cost comparison to see if it's worth it.
Yeah, interesting. So that would really only work for monitoring for flooding for
Mhm.
it would have to be low pressure to use the
Yes.
connectivity monitor. So the air handler is probably the most common application that makes sense because and we've seen that time and time again. Many customers are really concerned about freezing coils, or if it was some other critical process on a heat exchanger that was at a low supply pressure.
Yep.
Yep. So that could
Absolutely.
be possible. Another question here, any cost-effective method of trap monitoring so that all of the customers will be able to do it on their own? I'm not sure what he means by that, but I'll let you take a stab at it, Ian.
I'll take a stab at it. As far as and in all honesty, Chase, you actually I feel like answered this one a little bit earlier, and I'll reiterate it in the sense of a cost-effective way of trap monitoring your entire trap population is a hybrid method of monitoring a number of traps wirelessly while mainly hard to reach, process critical applications, and then the other portion of your trap population monitoring with yearly surveys, easier to reach ones that aren't as critical, so that way that you're not having such a large infrastructure, that it's incredibly expensive. In this situation, you're able to go at it from a cost-effective approach and also not bite off more than you can chew. So you're not having to hand test hundreds of traps on your own. You can reduce that down with that wireless monitoring.
Interesting. Another question. They're kind of coming in right when we finish one of those. Good
Totally
pace
fine.
here. Are Sage or SteamEye using AI or feeding into user systems to draw insights for the user to act? If not, are the industry asking for such features?
Currently, they are not utilizing AI. It is an interesting concept. As much as I can say, it has been mentioned, but as of right now, it's not current. The current designs are not utilizing AI, but it's a very interesting discussion that is happening in the industry.
Yeah, interesting. It kind of reminded me of another point, I guess, to these systems or something to consider is a lot of our customers like that they are standalone systems. So there's no concern about, tapping into their existing IT infrastructure for security concerns or anything like that. So just another point about the benefits of it kind of being a standalone thing, although it can also be integrated into the BMS as Ian mentioned.
Yes.
Um,
Yep.
All right, another question from Keith Carlson. Will the SteamEye data and the manual trap testing or UMT tested traps all be managed on the same Sage dashboard?
Yes, they will. That's actually the benefit of Sage is we have all of that data, whether it's coming from SteamEye or the UMT manual testing that's occurring. All of that is, as long as you have your SteamEye gateway connected to Sage, which requires a online connection. Essentially, that's all it requires. As long as that SteamEye gateway is connected back to Sage, which the majority of our customers do, both the UMT test and the SteamEye data is going to be compiled on the same Sage dashboard so that they don't have to go around clicking on the SteamEye site and then the UMT site. No, it's all in one location to minimize all the different passwords and usernames you ever need to remember on your day-to-day basis with all the applications you work with.
All right, great. Well, we'll have a few minutes. We're going to 5 more minutes. Everyone's free to drop off, but we do appreciate everybody attending. We will stay on and continue to answer questions until the top of the hour. And yeah, I want to thank Ian again for presenting and everyone for attending. And yeah, feel free to email me with any questions or if you would like a PDA certificate. And we have another question. Is the Sage limit measuring steam data, or does Canon thermal medium agnostic? Is it thermal medium agnostic?
As of right now, Chase, the
okay.
current use of Stage is to Steam systems. It is regarding the data that we're getting from Steam traps and the other monitoring equipment that we have that we can provide that are for Steam systems. So unfortunately, not at this time can we utilize it for thermal medium agnostic.
Okay. Great. I guess I would add, just earlier, somebody had asked, is there a cost-effective method of trap monitoring so the customers can do it on their own? I think we find our role in these systems is, as part of commissioning this type of system, you really have to put in all the trap data. So it's a lot of overlap with the surveying and testing that we already do. And so I think that's maybe where customers would struggle to implement it themselves, is not in understanding the Sage equipment, but being able to put in all of the correct trap information from make, model, application, steam pressure, required lift pressure downstream, all of the stuff that you want, in your dashboard or in your management system, all of that data that you want. I think that's where, that's where we find our role in commissioning these systems is, putting in all of the data and supplying the equipment and commissioning that. So, but I will say, I think it's a pretty, right. I do think it's a pretty easy to understand platform though. So once it is all commissioned, I think that users will find it easy to make adjustments as they need to.
Yes, absolutely. Absolutely.
Great. I'm not seeing any more questions. I guess just for fun, we'll hang on for another couple minutes. But again, thanks everybody for attending. If any questions pop up, we'll answer them. Otherwise, we'll close it out here in a couple minutes.